So very good morning, all of you. So in the last class, I have explained about the microwave signals in the class 1, and in the class 2, I have explained about the it is waveguides there. Okay, and the continuation of that one is the class 3. This is about the it is what energy coupling. It is in the unit 1 itself of the advanced communication, okay, subject. Okay, so in this online class I am going to explain about the what energy coupling, it's a definition. Okay, what's the meaning of the probes, and what's the meaning of the loops, and what's the meaning of the slots. Okay, all this is going to be studied in this class here. Okay, if you take the definition of the energy coupling, so what the definition, if you take the special device used to put the energy into the waveguide at one end, and to remove it from the other end is called as an energy coupling. Okay, so that in the last class I have explained about the waveguide. It's what's the waveguide? It's nothing but if you take the rectangular pipe, or it is made up of the conductor, or if you take the circular pipe, it is itself is acting as of the waveguide here. Okay, so that if you have seen the pipe means what happens there. So it is having it is assumed as the one end as an input side and the other end as an output side. ಅಂದ್ರೆ ಇವಾಗ ಒಂದು ಪೈಪ್ ತಗೊಂಡ್ರೆ ಒಂದು ಕಡೆಯಿಂದ ಏನಾಗುತ್ತೆ ಪಾಸ್ ಆಗುತ್ತೆ, ಇನ್ನೊಂದು ಕಡೆಯಿಂದ ಔಟ್ಪುಟ್ ಹೊರಗಡೆ ಬರುತ್ತೆ. So if you put the energy into the waveguide at the one end of the tube, and if you remove it from the other end, itself is called as an energy coupling. ಅಂದ್ರೆ ಇವಾಗ ಎರಡು ಪೈಪ್ಸ್ ಇರ್ತಾವೆ. ಓಕೆ, ಎರಡು ಪೈಪ್ ಕನೆಕ್ಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಅಲ್ಲೊಂದು ಕಪ್ಲರ್ ಅಂತ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಅಲ್ಲಿಂದ ಏನಾಗುತ್ತೆ, ಇಟ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಇನ್ಪುಟ್ ದ energy from the one end, and the energy is to be taken from the other end. Okay, in order to interconnect any type of the spatial device, in order to input the energy into the waveguide, and in order to take the energy from the waveguide itself is called as the energy coupling. Okay, so if you take the definition, I am going to repeat again. It is a special device. It is used to put the energy into the waveguide at the one end, and to remove it from the other end itself is called as the energy coupling. And if you take the methods of the coupling, okay, so it has been classified into the number of the types. So according to the syllabus has been considered, it is having the main three coupling methods. It is one is the probe, one more is the loop, one more is the slot here. Okay, so all these three are the important methods of the energy coupling. Okay, and the actual meaning of the slot, it's nothing but it's an aperture or the windows here. Okay, I will explain in the succeeding slides. Okay, it's what's the meaning of the probe here. I think already you know about the probes here. It is while connecting the CRO. Okay, so that you are using the probe. Okay, it's nothing but the same type of the probe. It is to be used in the energy coupling. It is when a small probe is inserted into a waveguide and it is supplied with the microwave energy. It acts as the quarter this wave antenna. Okay, suppose consider if this is the waveguide here, and in the waveguide, so that it is going to induce the probe. It is the core of the probe here. Okay, center wire, and if it has been injected, and if you take the length here, it is exactly equal to 1/4. Okay, which is indicated as of the lambda by 4. Okay, so that you can able to see it is 1/4 of the wavelength. Okay, it is when a small probe is inserted into the waveguide and it is supplied with the microwave energy. It acts as the quarter antenna, and if the quarter antenna has been inserted, means all the signals is to be get attracted to this antenna probe. So what The current flows into the probes and it is going to set up the E field. E is nothing but the electric field. It is such as the shown in the figure. So in the figure you can able to see after inserting it into the probe into the waveguide, so all the current of the E lines is to be get attracted to this probe. And in this case, the most efficient place to locate the probe is the center of the A wall. It is parallel to the B wall and it is 1/4 wavelength from the short end of the waveguide. So as shown in the figure 2. So this you can observe. So if you assume it is equal to the A wall and if you take this is equal to the B wall, okay, its name equal B, and it is to be inserted exactly at the center in order to catch the very good microwave signal. And it's a distance from the wall B. If this is of the wall B, its a distance from the wall B is equal to lambda by 4. And if it's take for the parallel distance, it should also be equal to the lambda by 4. And if it is inserted as in this way, it is going to catch the very good signal energy. Okay, so the most efficient place of it is to locate the probe is the center of the A wall, which is parallel to the B wall, and it should be 1/4 wavelength from the short end of the waveguide. If you take the size and the shape of the probe is going to determine its frequency, its bandwidth, and the power handling capacity. So it is what ability of the frequency it can able to catch, and it is what is the maximum the bandwidth it can able to sustain, and it is what is its power. So handling capacity all is to be decided by the size of the probe and its shape. And as the diameter of the probe increases, the bandwidth increases. Obviously, I think you know that if the diameter decreases, obviously the bandwidth is going to decrease, and increasing in the diameter of the probe increases the bandwidth here. Okay, so if you take the probe coupling, it's nothing but inserting a single conductor at the center of the waveguide, in which all the E lines is to be get attracted to this probe itself is called as of the probe coupling, and it is to be placed exactly at the lambda by 4 distances. So it is from the A wall and also exactly parallel to the B wall, and its frequency, its bandwidth, and its power handling capacity is to be decided by the probe size and shape. And as the diameter of the probe increases, its bandwidth increases. Understood? This is about the probe coupling. And if you take the loop coupling, so it's nothing but the coaxial cable. Okay, if you insert the coaxial cable into the waveguide and if the ends is to be shorted, it is going to form the loop here. You can able to see here. So another way of injecting the energy into the waveguide is by setting up the H field in the waveguide. You know the meaning of the H field. This is the magnetic field. And in the previous, the probe coupling, you can able to see it is to be set up by the E field. It is the electric energy. And this is the magnetic energy. The magnetic field is going to establish here. And it can be accomplished by inserting a small loop, it is which carries a high current into the waveguide. A magnetic field is going to build up around the loop and expands to it is fit the waveguide as shown in the figure B. See here, if the coaxial cable is to be inserted into the waveguide and if these two ends is to be shorted, it is going to form the loop. And after forming the loop, so exactly surrounding to this, it is going to establish the small magnetic field. You can able to see the small lines here. It is going to establish the small magnetic field. And after some time, it is going to be get expanded. So a magnetic field which is to be built around the loop is going to get expands around the waveguide, and it is itself is able to carry the microwave signal, and it is to be inserted where in the probe coupling, I said that it is to be inserted exactly at the lambda by 4 distance. And if you take the loop coupling, it can be inserted at any of the center place on the one side. So it is for the most efficient coupling of the waveguide. So the loop is to be inserted at one of the several points. It is where the magnetic field will be the greatest strength. So the 4 of the points has been shown here. So this is an upper wall. This is the lower wall, which is indicated as the wall A. This is the wall B, which is to be, it is on the left side, it is on the right side. So it can be inserted at any one of the points which has been shown. It is when the diameter of the loop is increased, its power handling capacity increases. It's very okay, normal. If you increase the diameter of the pipe, so what happens? So the flow of the water inside the pipe increases. Okay, no, in the same way, if the diameter of the loop increases, its power handling capability is also going to increase here. So the bandwidth, it can be increased by increasing the size of the wire in order to make the loop here. So this is about the loop. This is about the loop coupling. Okay, again I am going to explain. In order to establish the loop coupling, so a coaxial cable is to be inserted at one end of the waveguide, and what these two ends is to be get shorted, it is going to form the loop here. This is itself is called as of the loop coupling. And if any of the microwave signal has been applied, it is going to form the magnetic field around the loop, and after that it is going to be get expanded around the waveguide. That itself is called as an expanded magnetic lens, which is represented as a H field, and it can be inserted at any end of the wall exactly at the center. And increasing in the diameter of the loop increases the power handling capacity, and increasing in the size of the wire increases the bandwidth. This is about the loop coupling. And if you take the slot or the aperture coupling, it's nothing but an open window. Okay, if you take any of the pipe, and if you make the rectangular what hole, or if you make the circular hole, it is itself is called as the slot or the aperture coupling. If you want, means you can see this is the rectangular, it is the rectangular waveguide, and in this you can able to see this is the window has been formed. Okay, and if you see in the vertical section, if you take this as of the rectangular waveguide, and in this you can able to see this is the window andre open space. So if you make the slots or the apertures, it is sometimes used as when very loose or inefficient coupling has been okay desired. In this method, energy enters through a small slot, means with the small window. It is an open window, so the energy enters through a small slot, okay, into the waveguide, and the E fields expands into the waveguide, so that you can observe if any of the signal appears into the window. Initially it will stay, it is as the small signal at the window, and after that it is going to be get expanded, so as per the size of the waveguide here. Okay, so the E lines expands, it is first across the slot. It is first across the slot, and it then enters into the interior of the waveguide here. This is called as of the slot or the aperture coupling. Okay, so in this class, I have explained the actual definition of the energy coupling. So energy coupling means it's nothing but it is to put the energy into the waveguide at the one end, and to remove it from the other end is called as an energy coupling. And it is to be classified into the main three types. One is probe, one more is loops, and another one is the slot. The slot is also called by the another name as aperture or the windows. So in the probe It is coupling. It is going to make use of a single conductor. It is inserted into the waveguide exactly center. It is exactly the lambda by 4 distance from the wall. Okay, and after inserting the center conductor, all the E lines, so electric field is to be get attracted to the conductor. And if you take the distance, it is equal to lambda by 4 from the A wall as well as from the B wall here. And its bandwidth, its frequency, and its power handling capacity is to be dependent on the size and the shape of the probe. Increasing in the diameter increases the bandwidth. If you take the loop coupling, it's nothing but the coaxial cable is inserted into the this waveguide, and it is to be get okay shorted, and it is going to form the loop inducing the what H field. It is an the magnetic field, and initially it is going to establish the H field around the loop, and afterwards it is going to be get expanded, and it can be inserted at any of the points which is shown in the figure here. Okay, and increasing in the diameter increases the power handling capability in the loop coupling, and increasing in the size increases the bandwidth in the loop coupling. Okay, and if you take the slot or the aperture coupling, in the slot coupling it is an open window, and if the window has been kept as the slot here, so the energy is going to enter into the window, and afterwards it is to be get expanded, and in this case also it is going to flow the energy as of the E lines here. Okay, if you take the descriptive questions on this topic means he may ask you to explain. It is to define the energy coupling and to list the types of the coupling, or he may ask you to describe the probe coupling. He may ask you to explain the concept of the loop coupling, or he may ask you to just describe the slot coupling. Okay, so it is all about the energy coupling. So in the next class, so that we are going to see the waveguide modes of operation. Okay, thank you.